They evolved by steam, and finally, in the year 1902, they were electrified, right? These electrified trams lasted for almost 60 years. And they solved the problem, transportation. People move from one place to another, right? But then in the 30s, there was the Second World War, the Big Depression, and there was no money to maintain these transports. So the council had to take a decision. They needed to understand if they need to put a lot of money to repair and maintain the trams, or they are going to replace it by another thing. So what do you think that the council did? A refactor? No. They replaced it, the solution that they got that was working fine, with an off-shelf solution. And that's something that in our industry we see a lot. Someone new, or an architect, or a CTO enters to a company. He sees the code, or the base code, the projects, and he don't like it because it's like of everything, outdated, old versions. He decided to put another solution like Microsoft Dynamics 365, for example, right? So why did this? And this is the key question: why they did this replacement? And the problem was not the. I mean, the thing is, the problem was that they did this because of a tendency. This board was went into Canada, UK, USA, and their reports were based on what other people was doing around the world. They didn't thought about how to fix their problem, specifically here in Oakland. And that's the problem, tendencies. Here in our industry, some years ago, everything needed to be a microservice. If you have a monolith, okay, you are doing it wrong, because everything needs to be a microservice, and you need many small applications. The same with other things that, well, we are not going to discuss here. And to finalize this idea, I would like to show you this example of other countries, how they cope with legacy. For example, in Krakow, they got their trams in 1882 and it's still operational. Rome, 1877, still operational. Prague, 1875. And here in Germany, this is the picture. And to me, this picture is very fascinating. I mean, perhaps you just see two trams and that's it. But this is way more, it has deeper lessons here. For example, in the tram at the left, is from 1990. The tram to the right is from 1899. Sorry, the opposite. And they have more than 100 years of difference. They are working in the same space. They are solving the same problem. They are transport people from point A to point B. They are using the same interface. They are using the same railways to move one way to another, and they are using the electricity from the cables, both of the trams with the same interface. This is important to maintain the interface of our solutions. I think that's this picture is fascinating to me. So now entering to our area, to our discipline. What is legacy code? Can someone tell me what is legacy code? Because we have many definitions. And I'm not going to invent one here. So I'm going to quote the masterminds, people that knows a lot. Dylan Beatty says that legacy code is code that's too scary, it's too scary to update and too profitable to delete. Well, I think he is right? Because no one wants to touch legacy code because it's in production, it's making money, people is using it, and if you turn it off, people will, be angry. But I really like this definition, but it's not. It cannot fit with Argentum Online, because Argentum Online is many things. It's a success in many areas, but it has failures. And for example, one failure is financially. The game does not make money, and we don't receive any money from it. So this definition does not enter perfectly here. Michael Feathers, we cannot talk about legacy code without naming Michael Feathers. Michael Feathers said that legacy code is simple code without tests. I understand from what he is trying to say, but I think tests is our ability to be confident to change code and don't break it in the way. And Dave Farley says that the quality of a system is defined by our ability to change it. So these two quotes are very connected. And one quote that one guy in Microsoft in USA said is called Imo Landworth. He said this: people often say every code becomes legacy code, but that's not true. Only successful code becomes legacy. And he is 100% right. Successful code is the code that is going to become legacy, because successful code is the one that people are still using, is the one that is solving the problem, is the one that is making money. That's simple, because we can have the best code ever, 100% code coverage, but perhaps it's not solving the problem, because our job as software developers, as engineers is solving problems, not write code. So with that introduction to legacy and to legacy code, let's talk about Argentum Online. Argentum Online is an MMORPG. It's a massive multiplayer online role game. It was made in 1999. It's a fantasy world. You have warriors, you have thieves, you have wizards. But let's better make the game talk by itself. YouTube. And I'm going to put the music. This is the introduction of the game. As you see here, there is in this game, you need skills. Here is better, yeah. This is better. Yeah, this is better. Okay, so as you see, there is a lot going on here, a lot, right? It's a simple 2D game, but you need a lot of skills to play this. You need basically red versus blue players, but you can get guilds. So you need to play with friends, and it's well, you need a lot of skill. You need to know how to play this. But well, before further, you got a picture of what it is, how people play. Well, let's talk about. Let's continue. Oops. Okay, here we are. Perfect. So six points in the history of Argentum. It was born in 1999. In 2006 was the first commit to a CVS, to a source code repository. In 2012 was the latest version. From 2012 to 2018, we have what I call the blind era. The game was released as open source with the Aferro General Public License, but a lot of people in 2012, since 2012, were grabbing the code, doing some modifications, but they were not open source their changes. They were keeping from themselves. I was here in New Zealand in the year 2018. I wanted to see how the game was going, and I find this, right, that there were a lot of mods going on, and no one wanted to, share the changes. So I created a fork of it, AO Libre, Argentum Online Libre, and this one was the first mod with full compliance with the license. I put everything in order, and I uploaded to GitHub. Then, well, the creator of the game came to the team, and well, now it's in Steam. So yeah, how to work with legacy code, also known as Argentum Online. So this is my journey with Argentum Online, but this can be with any legacy code that you are going to work in the future, any, right? So first of all, don't fix everything at once, because you will see a lot of problems. You will want to rewrite everything or perhaps replace it with an off-the-shelf, right? But don't do it. Don't overwhelm yourself. Understand and acknowledge what is the problem that you need to solve. That's key, because otherwise you're going to be stressed. And this picture that I took from a talk from, it's called The Beginnings of the Opera and the Future of the Development. It speaks about the downhill invention and the uphill analysis. Software developers, they write code because it's fun, it's simple. You are creating the business model, you are creating the solution, and everything is in your head. So you can write code, simple. But another thing is when you need to read, I don't know, 40,000 lines of code from 20 years. So that requires time. That's the uphill analysis. It cost me a lot to understand all the evolution of this game. So yeah, this is very important when we're going to work with legacy code. The central problems that I found in this game was the following: no central development place, the thing that I just spoke before, almost no documentation, many years of unmanaged growth, no tests, lack of workflow, and very manual and difficult deployment. Okay, and so I'm going to talk about how I've been working with and just fixing one by one of them. Well, the first one, it's very simple. I just got the latest version that was in the CBS. And I also, this game had a lot of communities going on, a lot of posts. For example, you cannot see but here it says, a BB forum says, okay, get this line, then modify it by, put this value. In this file, get the other line, modify it by that value. And like that, people were sharing knowledge. So I tried to search for the best, how can I say, requests, or no, pull requests, in this way around the forums. And I started to putting them together. I spread the voice, and yeah, people start coming in, and pull requests starting to appear, right? But another problem, Visual Basic 6. Visual Basic 6 has many problems, right? First of all is single threading. First of all is obsolete. Microsoft is not maintaining it anymore, first of all. Second is obsolete. Is single thread. But the third one that is a pain, it was a pain, is that if you modify a line, a bus, a module file, right? And you modify any line of code, you will find a lot of these differences. The IDE is going to change the uppercase to lowercase to uppercase as it wants. So, okay, fantastic. They wanted to change two files. I got this, files 27, and then I got this, 34,000 file modifications. So this is impossible to review, right? This is impossible to review. At that time, I didn't care much because I was trying to solve another problem, the central development place. So, okay, I accepted because you're explaining to me what it's going to do. Okay, let's accept it. Let's do it. But then this became a real issue. So we fix it. And how we fix it? Okay, we create a bash script. We are not going to see exactly what this does, but this bash script, we attach it as a P webhook in the commits. What it does is going to put in lowercase all the files, our file too, and it's going to compare. If there is a difference between that, it's going to remove the false difference, right? In a nutshell, it's not exactly like that, but here is the script. It's open source, you can read it. With that, we increment drastically our workflow. And well, pull requests were fine. Again, they were reviewable. And well, we finish with a state-of-the-art organization in GitHub, right? Second, almost no documentation. I cannot say much about this. Just read the code and document as soon as possible. Document it, create diagrams. Don't create a C4 diagram. It doesn't need to be to that level of abstraction, but just at least draw something. And in the readme.md in the root of the project, most of the times is enough. So document. Put everything on Git. The deployment scripts, the compression, whatever you do with your project, right? Our pipelines are very hard, are very heavy. We are going to talk about that a little bit, but put everything in the source code. We have 3 repositories. One is for the client, the other one is for the server, and the other one is for the assets. In the assets, we have a folder that we put all the scripts and things that we need over there. We can manage control like that. Many years of unmanaged growth. Okay. On this one, it's a little tricky because you need to play the role of a detective, the role of an archaeologist, many roles you need to play here, because when you go to a new company, right, and perhaps there is no one else because everyone left, and you are now, it's your responsibility to manage 30,000 lines of code in 5 projects, but you don't have a team. So ask to your team, okay, what this does, ask to everyone, right? Well, what I did is when I went to all these forums and I went how the game was growing with the time, and this year, 2 months ago, I found a tool that is awesome. It's called CodeSyn. CodeSync is a tool that you can throw a whole organization, GitHub organization on there, and it can help you understand how was the growth of a project. It can help you understand who is the key persons, which is for files, for models, for whatever you want to do. And I really recommend it. And the owner of this, the creator of this tool is created, also wrote a book that is called Your Code as a Crime Scene. And this quote, I really like it, that said, treat your code as a crime scene. Use the evidence in your version control system to uncover and understand the social processes of your software projects. Basically, understand why things were made in one way, right? People sometimes, don't tend to think about that. Developers are just focused on the code. Well, no tests. I'm not going to talk much about this because really my point here is that it doesn't matter the technology. It can be Fortran, it can be Visual Basic 6, it can be the language that you want, COBOL, the language that you want, that I'm pretty sure that is going to have a unit test suite. Yeah, I'm pretty sure more if it is commercially, or you can do something to do some test coverage. But yeah, in our game, there is something in Visual Basic 6 that is called VB unit, but one does not simply have time for that, unless when we are not getting paid, right? We do this as a hobby. It's not a paid job. So lack of workflow. On here, basically, we didn't invent anything. We proposed the GitHub workflow: fork, create a pull request, review it, let's test it, and merge it. But here, the core. What I can get from this is educate people, teach your team. It doesn't matter that they are not professionals and they are not working in the industry. Teach them, because believe me that we got in our organization, in our game, we got people that they don't have any idea of how to work with code, or in professional environments, better said, in professional environments. But if you teach them, they will learn. And I have pull requests that they have way better quality than professionals that they've been in the industry. So, and also, it's very important, the open source values. Open source is for me, it's, I think, the most important, the only way to write code, right? Because we can learn from each other. So yeah, educate your people, spread the knowledge. Very manual and difficult deployment. And this one was key. I think without this one, the project will not grow as it grows, because when I just started and I was starting to understand how I can deploy something, it took me around 40 to 50 minutes to do a deployment, because it's a lot. It's a lot to do in a video game. So what can I say with my learning here is, open the source code, modify one line of code, a text, a color, whatever you want, and just try to push it to production and check how much time it takes to you, and start writing in a notepad, just in a notepad, all the steps that you need to do. Every single thing. Open this folder, put this zip over here, open the FTP, every single thing. And then start automating it, right? You can do it. I mean, we work in this, right? We do automation all the time. Do automation for yourself. Another thing that, Jenkins is from 2017. So, in the 90s or 2000s, this beautiful tool was not with us, but thanks to Jenkins and with some Bash, with some PowerShell, we got this. And today, we got this thing that I really love it. This is my best friend in life. So, yeah. I have some bonus track, because I thought that I've been practicing my talk, and sometimes it took me 20 minutes and sometimes it took me 35. But I have more content, so don't worry. But yeah, I wanted to, because when I did this talk for non-technical people told me, so you are against change. And I say, no, I'm not against change, but we need to understand what is the difference between obsolete and legacy, right? And for example, I wanted to put this Nokia N95 is completely legacy, because you will not find a developer that can do application. It just receives an SMS and phone calls. But in the other hand, a car that was released in the same year is still operational. It's not the best. It's not the latest technology, but it still drives. I mean, mechanic will still repair it. So yeah. In a summary, but we are not going to see the summary now because I have more. I have more. One of the things that we needed to, solve was these ones, that was the ineffective logging practices, and this was very important because let's see code. Let's see a little bit of code here. This is a Visual Basic 6 submethod, right? And basically, in this line, in the result, it's going to explode. It's going to have a runtime error. Is if I'm not wrong, division 0 runtime error. I don't remember exactly the error, how it's, but this is going to explode. What happened? If you see the last line of code, not the end sub, the resume next, it's this line of code, it will avoid that the program crashes, and it will continue with the next line of code. So everything goes fine, right? So, but what's the problem with this? You are not understanding that you have a problem. You are not logging it, right? So keep calm, on error, resume next. So yeah, I mean, this worked for years, but what happened? We needed to understand what was happening in the world, right? We have a virtual world. People does a lot of things. You have thousands of interactions per second. People throw a spell in order. Someone throw an item. Someone is trying to cheat it. You have many things. So you need to log. But what happened? Two main things here. Visual Basic 6 is single thread, and all the errors were logged in a TXT file. Okay, fine. You can say 1, 2,000, 10,000. Everything is going to be fine. But the problem is when you have a lot of traffic. Yeah, that's a problem because people started to say, "Hey, my game is laggy. What's going on? The game is not working fine." And well, we need to understand what we need to do. So we turn off the logs, right? And then the game was working, but we don't have eyes. So what we did, is, well, I wanted to come with this one. What we did is we implement some monitoring enterprise grade tools like Savix, right? So okay, we can have visibility on the server and also data governance, right? That's very important because a lot of people, developers, want to see the logs, right? And yeah, with that we could sort that out. But also that I wanted to talk about with you on here is this is Visual Basic 6, right? And I don't know if you can see something that all our IDEs have, even Notepad++, right? That is line numbers. Visual Basic 6 don't have line numbers, so you don't know where you are. You can just know that, okay, I am in this file, but you don't have an idea of where you are. Visual Basic 6, to do this, it has something that you can pre-append at the beginning of the line manually yourself the line number, because the error handling, it can be by 3 ways. One is on error resume next, the one that we just talked about. You go to the next line. The second one is on error go to line, and you can put the line number, or you can put the alias, like this one, on error go to registration error. The third one is on error go to 0, and it's going to disable. So yeah, well, basically we needed to add all these lines. You can put the number that you want. With that, we started to have a stack trace, and we started to understand what was going on with the world. But yeah, when people start saying that the game was laggy, we needed to do something about, because write in a file is expensive. Write to hard drive is very slow. Okay, because again, if you open a file, you go to the last part of the last position of the file, you append text there, you close the file, and then you go in a single thread. Okay, you are going to start problems, because every single thing that the players are doing, you are writing on a TXT file. So what we did is we changed the strategy. We start changing where we store the files. And now we started to store the files in the Windows events, right? And this changed everything because now we can start logging absolutely everything, and people, no problems. So that's a win for us. That was a very win for us. And thanks to this, I implement Zabbix. With this, but we have a lot of stakeholders, role masters, we have developers, administrators. Everyone needs to see different kinds of logs, right? The game masters want to see, okay, someone throw an item here. This game master teleport this guy to here, right? It's a virtual world, so you don't want advantages. Developers want to know when a function explodes, right? When you have an error, and admins want to see everything, IPs. So this tool gave us data governance, let's say, right? And now game masters can see in Discord the logs. Forget about the description event ID 0 because that's something that, but at the end you can see sugar said suerte or cheating log, you know? So the point that I want to make with this is that let's remember from where we start, right? We have a project with anything, no documentation, no anything, and now we are implemented enterprise grade solutions, right? So with data governance, then DDoS attacks, okay? And this one was tough for us because, yeah, what can I say? People is, screaming that they cannot play, and you are stressed because you don't know what's going on. You cannot access your servers because they are completely in an attack. So yeah, all of these types of attack we suffered from application layer, from protocol attacks. What I can say is, okay, in this we solved this with many solutions, right? The first one was starting to remove some functionality from the main server, like the login, the register, and so on, in microservices, right? But the second one is, okay, how do you connect computers in the internet? You don't have any other option that expose something, expose an IP and expose a protocol. So, well, we fix it. We try to put this protection of Azure, the DDoS protection that you pay $200 per month, but it didn't work for us because the only thing that it gave us, it was a graph that said under attack, yes. So we try to understand and see another strategies. And the creator of the game told me something that I will never forget. Come back to the roots, because I was thinking about application gateways, load balancers, and all this jazz and all this jargon. And he said, okay, let's put firewalls and let's put a virtual LAN. So what we did is with Azure Virtual Machine scale sets, you can have until 1,000 virtual machines. We expose those IPs of these virtual machines, and the server, we hide it. It's not exposed to the public. This virtual LAN and these virtual machines with the firewall is connected to the main server, are going to redirect the connection to the server with NAT, network address translation. So with that, we solve the problem attack of DDoS, because, okay, you attack me with 100 computers, doesn't matter. I can just press a button and put 100 computers more, 500 computers more, up to 1,000. So yeah, I think we're okay with time.
Yeah, you got about 2 minutes.
Good. Okay. Okay, good. 2 things more I wanted to say. Again, our problem again is that financially we are a disaster. We don't know how to make money, and that's a problem. All the money that comes in, it goes to servers. It goes to Microsoft. Yeah. so yeah. But one thing that I think is, I never saw this in other game, in other kind of project, is that it's community driven. So people have their characters, right? What they like to exchange characters. And what we did is a market. And they can sell their character for real money, and we will get a 10% of it. So with that, we help to pay the rent, So yeah, no, this is very cool. It took us like 1.5 years to develop it, but everyone was happy. The last one, everyone I think here knows who is this guy. This guy is Guido van Rossum, is the creator of Python, and he is the guy that creates the terminology benevolent dictator for life, right? When you see the word benevolent, a dictator, it's like scary. But basically, what he says is that there is someone that needs to put some kind of order or kind of decision making, right? Because you will get a lot of pull requests, you will get a lot of changes proposed by your community, by your players, but somehow you need to see that those changes do not affect other things of the game. For example, we got proposal to close source the game, right? And that's not an option. We are not going to close source the video game. And yeah, that's why open source maintainers, a lot of them, Linus Torvalds too, they get this title. And it's not, believe me, that it's not a title, it's not a position that where you want to be, right? It's tough to deal with people with a lot of things coming in. But yeah, I just wanted to say that the benevolent dictator for life is not a angry and nasty person, right? It's someone that is trying to maintain order in a project. That's it. Thank you so much, Baichu, thank you so much for your attention. Sure.
Thank you very much for this talk, Lucas. You're an amazing admin. Greetings from the community of Argentum Online.
Thank you so much. Thank you so much, guys. Awesome. Thank you.
Let's bring Axel in now. For online, yes. Easy.
Nope, that's the wrong one. Trying to get my connector sorted out. There we go. Okay, can everybody see that? All right, thank you very much. Hello, everybody. My name is Axel Matthäus. I am a data science cloud solution architect at Microsoft. Today, I want to show you, or perhaps I should tell you a little story. So back in the 90s, I went for Excel training. And I remember after a couple of days, when I walked out the sessions, when we were finished with the course, it's like, I don't know how to do any of this stuff, but I know when I see a problem that there is a menu item out there somewhere where I can go and click and do it. So if you as a group here today have that same experience, don't remember everything, but at least when you're in front of the environment, oh, Axel did something there and it's created something over there. That would be a good place for you to be. So I don't expect you to understand everything or to memorize everything. I just want to give you an overview of what the ML Studio environment is like. Right, so first things first, we have Studio Soup at Microsoft. We have Copilot Studio, we have AI Studio, we have ML Studio, we have Visual Studio, we have Visual Studio Code. Today I'm going to show you ML Studio. So what are the different studios? AI Studio is if you want to build solutions that work with generative AI models. So basically that is the open AI models and all the other models that we host for generative AI. Last time we had to talk about generative AI models, so but that's what you use AI Studio for. Copilot Studio, you use to build what? Anyone? Copilots? You build copilots with Copilot Studio. So I'm not going to show you Copilot Studio. So today I'm going to show you how to use ML Studio, how to set it up, what are the prerequisites to use it, and what I'm basically going to do is I'm just going to take you through the training material, and I want to encourage you to go and do it yourself after the session. Go and play with it. So here I have my subscription. It is a Microsoft paid subscription. It's a FTPO, so that's for demo purposes only. It's quite nice to play, and I have all the rights that I need. That may not be the case for your organization. So what I have here is I've created a resource group, and inside that resource group, I went and I deployed a machine learning resource. So basically go deploy a machine learning resource. And this is the guy over here, that's its name. And when I go to the machine learning resource, look at its name up there, Azure ML 2024-06-12 open. It has the default settings that you are familiar with in a lot of the services. The ones that your security team is going to ask you about is, can I isolate my environment? Can I put it in its own network? Yes, you can. They're probably going to ask you, can I manage my own certificates? Yes, you can, but don't. The operational guys are probably going to ask you, can I monitor it? Yes, you can. Can I attach a log analytics workspace to it? Yes, you can. Right. So that is the basic overview of the ML Studio workspace. Now, if I click on this little button here, it takes me to my ML Studio, right? So it will open ML Studio for you. And so what we have here is the basic layout for ML Studio. So let me show you. There's a couple of things here. There is a generic box at the top there. Then we have the authoring section. And who wants to take a stab at what happens in the authoring section? Anybody?
Create your models.
That's where we create our models and write code and all that kind of stuff. Then we have an assets section over here. Okay. Anybody wants to take a stab at what assets are?
Sample data.
That would be reusable components. So if somebody wants to build a second or a third model and you want to easily expose data to them, you put that goes into the assets section. And then finally at the bottom, we've got our management section over here where we set up compute and that kind of thing. All right, for you to use this tool, what you need is a workspace. Now, I already have a workspace. There it is open. And then you also need compute. So there's two kinds of compute that we're going to speak about today. The first one here is just a virtual machine that I can run my environment in. So that is what this compute is. Then there's a second kind of compute. It's compute cluster. And a compute cluster is where I train and inference, or where I train my models. So you need two kinds of compute. You need compute to just basically run your environment in, and the second kind of compute is for you to train your environments. Other kind of computes that you can set up Kubernetes clusters, you can run serverless compute and all those kind of things, but the basic ones, I just wanted to show you the basic ones. All right, so let's drill into the notebooks. So notebooks is basically Jupyter notebooks, and that's where we would author our models and do all that kind of stuff. You can see here that I have source code that already exists. When you first create your workspace, you won't have that. What you will have is you'll have this samples section, and what you basically want to do is you want to clone this get started notebooks bit here. So once you clone that, you get your get started notebooks cloned into your files. So that's basically, there's a template that you can just reuse. And when you clone it, you get it. And these are the files that you can now modify. So it's your own files. So your files over there, it's your own files. And samples is basically just a repository where you can clone your environments from. Okay. So how do I use this? I want to encourage you to go to learn.microsoft.com and then search for Azure ML Studio. Okay. Once you get to, or Azure Machine Learning, one of those. Once you get to the landing page, go to the tutorial section and then start with the basics, right? So that will basically take you through a tutorial. But if we have a look here at our cloned environment that we have, here we have a Jupyter notebook that basically have all the content that is inside this article, okay? Inside this article here, you also have it in here. So basically the same content that's in there.
Question.
Yes.
You said you clone from your samples.
Yeah.
We did it.
So you go to samples and say, I want to do Azure in a day. Over here, sorry, let me just zoom out a little bit. You see 3 ellipses over here. If I click on that, you see clone. Okay, and when you clone, it will then ask you for a target directory where you want to clone it to. You go ahead and you clone it. Okay, that was a very good question. Thank you very much. All right, so I'm just basically going to follow the steps inside the tutorial. I'm going to start with prepare your data. And then I'm going to go to train a model. And then I'm going to go to deploy a model. So those are the 3 things that we're going to cover today. So I'm not going to cover everything. Remember, when you walk away today, I want you to know where the buttons are, what you need to click to make things happen. Okay. So here we are with explore your data. So I've gone to the explore data notebook. And first thing that we need to do is we need to download some data. I've already done it for you. It will ask you to create a directory for you. So you create the data directory, you download a data set into that data directory. And then for us to use this environment, what we need is we need ML client. So ML client is basically a construct that connects my notebook to my backend environment. So remember, my backend environment, we've got all sorts of things. We've got storage accounts and we've got log analytics. All that is created for me when I create my ML Studio. So that client basically connects me to that backend environment so that I can copy files into directories. That will basically copy them into storage accounts. It will give me the capability to run a virtual machine and that kind of thing. So that is what the ML client does. So after we've created our ML client, I can then go ahead and I can connect to that client, but it's kind of a long URL. Here you can have a look at the URL and it looks kind of scary. There's a shortcut that we can use is we can basically create an asset, a data asset. So basically this file that I've downloaded, I can turn it into a data asset with a simple name. And this little script here, what it does, it basically creates the data asset for me and it sticks it inside the that data directory for me. And there it is, this credit card data directory. So I've downloaded the CSV file. The CSV file has information about credit card usage, and we're going to use the CSV file to determine what the probabilities are that somebody will default on their credit card. Okay, and I've created a data assets from that with this little script over here.
Is that your credit card?
So again,
Your credit card?
my credit card is is with my wife, and I don't know what's going on there. Um, I don't ask.
It's just
Yeah, I just ignore the notifications on my mobile phone. Where are we? Okay. So I have downloaded a file, and what I want to do now is basically I want to read the information inside my data file. For that, I use a library called Pandas. So there are a couple of these, but Pandas is basically a columnar storage structure tool. So when we download CSV files, the data is stored as records. So each line has some kind of information that sits on it. So if it's a person, that would be given names, family name, date of birth, blah blah blah, that kind of stuff. But in data science, we often work with the columns, so it makes it really easy for us to access something like, I want to just access all the date of birth for persons, so just that column, and filter out all the date of birth columns that has no data in it. So it makes it very easy for me, and Pandas basically gives me the ability to do that. Right, so here I've got my Pandas. I pull out the basic information of that file that I've downloaded. And here I notice interesting things, like this file that I have has two sets of headers. Look at that. There's x1, x2, x2, blah, blah, blah on top. And then there's a second header that's got descriptions in it. And then I've also got my data that sits inside my file. And I can then go and read that CSV file and rename a column. Again, it's easy to do a column. And I want to drop the ID on the long axis 1. So in a data frame, that's what the Pandas reads a data frame. So think of that as just one big matrix. Everything that sits along axis 0 is basically the rows, and everything that sits on axis 1 is basically the columns. So basically go and drop on axis 1 on column number 1, the ID column. So I just basically throw that away. And now I go and I save my file in a columnar specific format that is a Parquet file. So that is Apache Spark, and that makes it easier for me to use that file. Okay, so I've basically gone, I've saved my file. I now go, when we create data assets, we create a versioned data asset. So when I first saved my data asset as a CSV file, it was version 1. Now I've modified my file. I've turned the CSV file into a Parquet file, and I go and I save it as version 2 of my data file. So let me go and show you here. So if I have credit card here, we can see that we are on the cleaned version. So I basically removed information from the file, while the first one was the initial version. So that was the CSV version, and the latest one is the Parquet version. So as you work with your data, you get different versions that you save your files under. Okay, so it makes it easy for you back to go to your pristine data, your original data, or anywhere in the middle. Okay. Where are we? I now go and I just pull out some information about my data. So you can go and play with the script. You can see it basically just pulls out some information out of your file. And that is it. So that handles the data aspect of using ML Studio. So what are the things that you need to remember? Is I can access data sources on the internet via my console that I have. So I can pull things down. If you have deployed your service to access the public internet, if you haven't deployed it, obviously you can't do it. So then you have to upload data into your own environment, into your own storage accounts, and you can pull it from there. Again, make the security guys happy. What is the second thing that we've seen is we can then access that data with the standardized libraries like Pandas, and I can then modify my data. I can save data as an asset. And as soon as I save it as an asset, it has a version. my modified data, I can then go and save that again, and that creates a second version. So I have full stack of how my data evolved. Right. So that's it for data. Next, we want to have a look at training a model. Now, I know the title says that it's a neural network, that I'm going to show you how to do a neural network, but I'm not going to do a neural network, firstly, because it's not in the tutorial. In the tutorial, we have basically a gradient boosting. There are different ways that you construct models. So you have your neural networks. That would be convolutional neural networks, or it would be gated adversarial or recurrent neural networks. The gradient boosting is a separate way that you model and train data. Gradient boosting is basically a set of decision trees that you train to accomplish some kind of task. Let me give you an example. So if I want to distinguish between cats and dogs, I can have a convolutional neural network to do that, or I can have gradient boosting. So gradient boosting would be a decision tree. So if I show gradient boosting a picture of an animal, and it's a cat or a dog, I can say, does it have pointy ears? If it has pointy ears, it's probably a cat, right? Does it have whiskers? Yes, it probably has whiskers. If it's not, it's probably a dog. Does it have oval pupils? It's probably a cat. Not. So gradient boosting basically makes up a decision tree that asks classification questions, and based on that, it builds a model, and it's quite neat. And for what we have here for the demonstration, to train the models is really lightweight. If it was a neural network, it would take about half an hour. Gradient boosting to train the same thing would be less than a minute. But gradient boosting has a limit as to its accuracy, while a neural network is much more accurate, but it takes longer to train. Right. So again, I need that thing. I need a client. Right. Where do I get this information? You're going to ask. Well, here it sits. It sits in here. So there's my subscription ID. There's my resource group. There's my workspace. Right. So that's where I get my information from. And what does the client do again? Who can tell me? It is just
And configure.
it's just basically that connects to that backend for me. Okay, so I'm always going to need a client. So every new notebook that you open, you're going to need some kind of client, because that's going to connect to that backend for you. Right. Over in this specific instance here, we use specific instances of something like scikit-learn. There you can see we use scikit-learn version 1.02. So in this example here, this is perhaps a little bit too technical, but I'm just going to quickly go through it. Is for each notebook, I can create a specific environment for its dependencies. So if I have one notebook, and in that notebook I access data, and in that notebook I use a scikit-learn library that's a certain version, I can create an environment for it and attach it to that notebook. Here I'm on a second notebook here, and I need different versions of the libraries. I create a second environment so that I can run my my notebook. It's a little bit like, think of it. It is actually a Docker image. It's like it works. So basically, what it does is it creates a little environment, a Docker environment for you at the back end, complete with all your dependencies, so that this notebook that you're working on can continue functioning. Okay.
In real life, you normally tend to store it in a requirement.txt file, which is how you define the requirements for your book. Becomes version controlled.
So when I run my little script and I use my ML client, the one that connects to my backend environment, it will create an environment for me as an asset. right? And it's something that I can version control, right? So whenever I run this script, so a lot of the times when we run these environments or when we run the script, what it does is that ML client will inject that environment for you into the backend. If I then go and I change the version, but I keep the same name so I go and change a version of a library and I run it again, it will create a new version for me in my assets. Okay, thank you very much for asking me about that. So no need for a requirement.txt file. All right, what happens here? I create that environment. That's basically what's happening here. That stores it for me inside that assets directory. So what do I need now is I am going to create a source directory, and then I am going to basically save this file into the source directory, and I'm going to save it as main.py. So there we go. What is this file? So this file is basically a driver for me that I can specify command line arguments, and the command line arguments would be what would be the input path of my data, what would be the train test ratio, that kind of thing. So it's basically a driver for me to set up my training environment. So you can go, again, I'm not going to take you through everything that's in here, but I think the important things that we need to do is I have a data set. The data set maybe have 100 records in it. I want to have a 90-10 split for training and testing data. So this little script here will then go and randomly select 10 data sets or 10 records for me as my testing set, and it would use 90 as my training set. So that's what we need the little script here for. Okay. Where are we? Train model. Okay, there. I've basically gone and saved that script. And you'll see that as I run my script, there are statements inside my Python code that will create directories for me. So initially, the source directory wasn't part of my environment. If I go back to my samples over here, you can see my get started notebooks only has a deploy and a media directory in it. But you can have a look here at my files, and you see there's my dependencies in my media or deploy in media, but there are also other directories. So as I run my scripts, these get created for me. And again, it's that client that accesses the backend storage for me and creates the environments or the files for me in the backend storage. Okay, so what I do here is I submit a job to run that main file. So that will basically do the training for me. And when I am done, I will have a job. And there's my get started notebooks job. And as part of the training run, there was a prediction for me. I can have a look at the metrics, see how good my model is. And I can see here that the training accuracy is 83%. So basically this model that I've trained is 83% accurate with regards to how probable it is that somebody will default on their credit card. I can also have things like images for like the confusion matrix. So go and read up on metrics for how accurate the model is. I'm not going to cover it here, but you can see that if I run a job, all that information is extracted for me and it's made available. So I can go and have a look at it a little later. All right, so what did we learn? We saw that we can basically create a custom environment with our own set of libraries. Then we used a scikit-learn gradient boost to train our model. When we trained our model, it went and it created a job for us. That job is where I go if I want to see how accurate my model is. and I didn't have to do anything. I didn't have to store it anywhere. So remember, it's that magic that sits in that ML client that does all the work for me. So as I run my job, that ML client harvested the logs for me, it did all the calculations for me, and it stored it inside my assets directory for me over here. So that's why we create that. So you would know in a traditional world, I guess, that I will have to go and save that information myself. So I'll have to have some kind of log somewhere, and then I've got to commit it. While over here, I just go ahead and I create my ML client, and all that backend information is stored for me as assets. Yes.
Is the job static one? Assuming that you have a data that keeps flowing in. Every time your data parameters changes, so you would trigger a new job, or would you be triggering a new job ID of the same job?
So what I'm not going to cover today is pipeline. All right, because we don't have enough time. I think we've almost out of time anyway. So you would use a pipeline, and a pipeline would create a version number of a job for you. So you'll see all your jobs. It will also do things like it will also do in jobs. It will also you can provision what's called an experiment. So I can run a couple of different models, and the job will say, oh, this model here is the best one. So even that happens for you automatically. It's part of pipelines, but I'm not going to cover it. We just don't have the time to do that. Right, last one, deploy model. So I have downloaded data, I've modified my data, I have trained a model, I've seen how accurate my model is. Now I want to deploy my model. And what are the first thing that we need? The ML client is going to connect to the backend for me, and it's going to do all the magic for me. Okay, there's my ML client. So what do I do here is I go and I create a new model that I save in the backend. And what does ML client do for me? It sticks it inside the models asset for me. So you can see I've trained it twice. Okay, and you can see the versions of the model. I confirm that the model exists. And now that I've created a model, I want to serve up that model to the outside world. And I do that with a endpoint. Okay, so for me to create an endpoint, I basically say, take this model. So I've got an endpoint name. And I then create my online endpoint. And when I deploy my endpoint, I need a couple of things. I need a name for that endpoint. I also need the model that it will serve up. I also need the environment that that model runs in. Again, if I have different models that use different versions of machine learning libraries, for each one, I can have its own environment. And what will happen is there is an inference environment in Azure that this endpoint is going to be deployed in. Think of that again as just another Docker deployment. So it's Docker that gets deployed with exposed ports. These ports are mapped to endpoints so that I can access those endpoints for me. Right, there we go. I have deployed an endpoint. Where should I find that thing? Is it an asset? Yes, it is. It's inside my endpoints. There we go. There's my endpoint. And then for an endpoint, I can create multiple interfaces. Like in this case, I have, you can see over on your right-hand side, there's a blue and a green interface. So blue would be blue-green deployment. So as soon as I deploy my endpoint, there's just a default, all the traffic goes to it, but then I can split the traffic between a blue and a green and a red or whatever. In this case, all my traffic goes to my blue traffic allocation section of my endpoint. And then I can go and I can test my endpoint. Where do I do that? There's my blue deploy. And over here, I go and I test my endpoint. Blue is running. And here is basically a payload that I'm going to send to that deployment. And if everything goes well, I should have a result on what are the probability that this credit card will default. Print the logs. This may take a little while.
For the endpoint, is it?
Yeah, so what's happening here is if we go to our compute cluster is starting up. So that's what's happening here. Okay, so I know that I spoke about a lot today. So go to learn.microsoft.com, search for Azure Machine Learning, go to the tutorial section, deploy an Azure Machine Learning service. In the Azure Machine Learning service, you have access to the ML Studio. Go to ML Studio, clone the getting started samples, play with data, play with training a model, play with deployment, and I hope that you will remember the shape of how to use things. And that's all. So if you leave here today and you know that Axel said something about blah, and that's where we find it, I'll be happy. Thank you very much. Do you have any questions?
Yep. Sorry, that was quick. I'm Boris. I work for Holmes, and I'm a data engineer. You've been talking about training a model, but as a data engineer, I'm really interested in data preparation. Is there anything to help with feature engineering and actually data preparation? When you have a big data source, sometimes you don't really know the shape of your data, and you need to explore and understand the shape of your data before you can train the model. Is there anything in these tools that helps you doing this, or is it still manual with like traditional creating graphs and stuff?
So what we suggest you do is you use Azure Fabric as the environment where you would explore and clean and manage your data, get it ready for training. Again, what are you going to use to access Fabric? You should know.
To prepare the
Using and data preparation.
What's that thing that you're going to create? Client. You're going to create a client. Client's going to have a backend. It's going to access the backend for you, right? So the client is kind of like the magic that you use to access storage, to access compute, to access network security, to publish environment. So what you're going to do is you're going to do all your preparation in Fabric. You're going to use client to connect, to pull that data in for you to train your models.
Previous model, I think it runs like the accuracy is like 80% or something. Like, how do you do the fine tuning of your model?
So fine tuning of your model. So over here, what you would do is you will probably run so there's different ways. Over here we have the gradient boost mechanism. So I'll basically create a deeper set of trees to run. I can run more epochs. If it was a classic neural network, I would tune the networking architecture. So I'll add more hidden layers. You can also tune your hyperparameters like how many epochs, what is my machine, my learning rate, those kind of things. So that's all things that you can tune in your environment. You can actually run multiple environments at the same time. So remember when I ran my job for getting started in notebooks, if I run multiple jobs, one for a ANN, so artificial neural network, I have another one for a gradient boost. And I have a third one where I do transfer learning. It's something that I downloaded from Hugging Face. This job would have 3, it would be called an experiment and will tell me which one is the best. I can then go back, tune the hyperparameters to see if I can improve. So it would be more like you tune a traditional model. If you tune your hyperparameters or you change your neural network architecture.
You run like TensorFlow on this platform, or like just on a similar platform, or you have like to use like a separate
So this environment is basically dependent on Conda. So everything that you can provision with Conda, you can use over here. So Conda would provision pip for me. So with pip, I can then go and use TensorFlow, PyTorch, scikit-learn, XGBoost, whatever. So you just use it as normally, you use your pip. And that is where you create that environment. So if I have a special environment for a specific notebook, I go and I download that information with pip, or I go and I create that environment configuration, that YAML file where I specify the dependencies and then import that for the specific notebook that I'm working on, and that will serve up the environment for me. So no, it works.
Interesting point on just follow up on the previous question. When you're saying that the Conda is a primary repository system management system, does it mean that all the packages and Python packages are always downloaded from the internet? Or does ML Studio and ML infrastructure support pointing to another dependency management system?
So it would be similar to virtual machine images. So they would be hosted in Azure and synced with the external environments. So you probably won't have to go out on the internet. You just pull them from a Azure hosted repository. Yes.
I just, share the endpoints or model or, publish it so someone else could access it.
You could, yeah. So if I go to an endpoint, you can have a look at my deployment. Where is it? There's my we don't do it again. I know you can do it, but yeah, there you go. How do I share my endpoint? So basically, there's the URL, and that is the key that you're going to use to access it. It shows you at the bottom here, how do I set up the code so that I can access that endpoint.
The second question would be, what would be the difference or the advantage compared with, a Jupyter notebook or a Colab?
So Colab is just another hosting environment for things like notebooks. You can develop in Colab, but you will have to export your notebook and import it in this environment to use it. So you're welcome to go and develop on Colab. It's one of my favorite environments. I really like it a lot. I think what you get with ML Studio is the client that creates all my assets for me as I work. So whenever I create an endpoint, or whenever I work with data, or whenever I create a new model, that is automatically turned into an asset for me, so that somebody else can come and reuse it later, while I don't have that kind of integration with Colab. You could have Jupyter notebooks running locally with the connection into Azure, so you can use Visual Studio Code for your development. And as I develop in my Visual Studio Code environment with my Jupyter notebook environment, that will be synced to my cloud environment.
The way of putting it is ML Studio gives you a runtime environment. Your model, train your models, and deploy your models as well. Those three are basically the IDEs on which you are developing the models and the notebook configurations and the part of the story.
And then also in Colab, everything is, you don't have any dedicated compute. So I can go and I can provision an environment and say, I want a Tesla GPU, or I want Volta, or I want ADA, or something like that. But that's all I can do. With Machine Learning Studio, I can go and say, I want to provision this virtual machine to run it. So something with 128 cores and 512 gigs of RAM, if you want to go that far, with 10 V100s, if you want to spend $6,000 an hour. So I have very fine grain control of what my runtime environment looks like. Any other questions?
Questions from online?
Okay, cool. Go and play with data. Go train a model, and go deploy it. Learn.microsoft.com, Azure Machine Learning. Thank you very much.